We have a MacBook Pro 15 inches touch bar. This is a 2016 touch bar, 15 inches. It's an A1707. The board number is 820-00281. That's the board number. We already have the schematic open. It's as you can see, it's A1707. The board view. Let's now open up the schematic as well. It's 0-00281. Okay, loading up the schematic. That's the schematic. Now the description of the machine. It's a low power. Client said that at some point the machine would try to start, but now it doesn't start at all. So what we want to do, remember, I say, so there are two descriptions that usually goes with the machine. So the first description is a description of the client, the owner of the machine, who will tell you, okay, this is what it does. Now, you as a technician, in order for you to work on that machine, you need to now redefine the state of the machine, because only when you redefine the state of the machine will you have a basis to work, or will you have a procedure or process to follow. So first thing we want to do is we want to confirm the state of the board, and then we can now continue from there. So first thing first we want to do is we want to see what we have on our PPDCN. For this machine, for the touch bar, we are expecting to have 20 volt on our PPDCN. I'm just going to show you guys. So there are four CD3215s. Because the machine has four ports. There are four CD3215. There are four USB-C port controllers on the board. Each port it's supposed to have 20 volt on the PPDCN. So let's go to U3100. That's one of the CD32 15 port. Let's go to the schematic. I'm just going to show you guys what we should expect. U3100. So PPDCA, as you can see here, PPDCA is supposed to be 20 volts. So that is the first thing. First, we want to confirm what do we have. Let's see if we have our PPDCA. Now, for these machines, for your touch bars, 13 inches or 15 inches, whenever you're working on them, obviously, especially if you are dealing with a low power, you want to confirm if you have 20 volt. If you don't have 20 volt, don't waste your time, and you cannot get anywhere without 20 volt. So first thing you want to do is you want to see if you have 20 volt. So we want to grab a DC in jack. Get a DC in jack, and then see if we have 20 volt on our PPDCN. Connecting our USB-C charger. I'm not using an amp meter. I used to use one, but now I just decided not to, and then I just don't use one anymore. So let's see if we have our 20 volt. According to the way the board is aligned, let's just quickly go to our board view, flip it to the other side, flip it again, turn the board. So we are connected on this side of the board. So yeah, let's measure our 20 volt on one of the fuses. Let's see what we get. and we have 5 volt. So at 5 volt, okay, 5 volt, let's say, is it fluctuating? Okay, so we have 5 volt and it's fluctuating. So that's a good thing. I'm going to explain a little further why that's a good thing. So what we want to do is we just so we can check on this fuse here. So now this, so you see the fuse here corresponding with this CD3215. So that tells you that this fuse here is corresponding to this, and this fuse here corresponds to the other one. So U30 UB300 is going to correspond with if with this, and then this is going to correspond with UB400. So first thing, we are checking at the port of UB300. So UB300, let's just see, what do we get? We have 5 volt and it's fluctuating. Now that is good because it tells you that the port is trying to it's trying to do its work. It's trying to boost. So that tells me that that port or the CD3215 controller is healthy. That's a good thing. That's a partial communication. It's not complete. It's only going to be, my assessment is only going to be complete if all of the ports does that except one. So I expect one to be stable at 5 volt without trying to post. The one that is stable at 5 volt without posting or without moving up is the one, or without going up and down, is the one that's going to be faulty. So I'm just going to repeat that again. So what I want to do is I want to go over the whole 4 ports and see if I get the same reaction as, so when I have my, as obviously I have my multimeter set to voltage mode. I have my black probe on ground, and then I have my red probe. I try to measure from one of the fuse, and then I get 5.2 volt. Now it drops to 0 and then starts again. Now that is a good thing partially. So what I want to do is I want to see if that is the same thing across. So I expect to have this same reaction across all of the ports except one. Now, the one that is not going to fluctuate will be the one that is faulty, which is because it's just because that is the one that is not doing anything. So let's try the second port and see what we have. Try the second port and see what we have. That's a good thing. The second port is doing exactly that. The second port is it's doing exactly that. Okay, yeah, that's a good thing. Now let's try, and now let's check on the other side of the board. Let's see on the other side of the board if we have the same reaction. Now on the other side of the board, I'm just gonna flip my board view to, so I flip my board view. Now this is the, so now let's just flip it this way. Okay, so now we want to measure for our 20 volt here, which is U3200. Now we will use a corresponding, the corresponding fuse is going to be this. F3100 is going to be the corresponding fuse to U3100. So let us see if we have, let's see if we have, let's see what reaction we have on U3100. Five volt, and then it drops. Now that is good. So let's hope that, so okay, fine, because remember I was saying that that is a partial communication. Now that's a partial knowledge that we have. It's not the the assessment, or the pre-assessment is not complete until we measure the last port and see if it does the same thing. So if the last port does the same thing, then we have, if the last port does the same thing, then we know that we may have a short. That's why we may have a short. That's why the CDs are not actually boosting, even if they are trying to boost. But if the last port does not do that, then it means we have an issue with the controller of the CD3215 of that port. So let's see what we have on that port as 5.2, and is not fluctuating. So that is good. So that tells us that the issue is this particular CD3215 on this section. Now, So the other three, if the other three were, if the whole four ports were actually giving us the same reaction, then obviously we wouldn't blame any of the CDs. It means they actually trying to do their job. But because there is an issue beyond the CD3215s, that is why they are not basically boosting to 20 volt. But now, because because we have four CD3215s and then three are trying to boost, but one is not. Now, what that will mean is the CD3215 that is not boosting at all is the one that has a problem. It seems ironic because the three ports, they fluctuate up and down. That is actually good. Now, the one that is not fluctuating, that is our problem. So the first thing we want to do is we want to remove and then replace that's CD3215, and then we take it up from there. Let's see if so after replacing, we'll see if we have any changes. If you can maybe switch it to cinematic mode, because that way it can track my movement. You understand? I don't know what you think. No. You understand what I'm saying, though? Yeah. Because otherwise, you might not one might not be able to really track. So our CD is out. So what you want to do is we want to prepare that section of the board and then replace it with another one, and then try see what we get afterwards. What? Change what? Cinematic? Yeah. Cancel? No. You just choose cinematic. Is it? How? So is it? Since when? I thought you could just change it. Can you set it at least? But 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 are you able to see what I'm doing? Hi. Are you able to see what I'm doing though? Say again? Did you cut the video? No, don't. Peter, now another thing, see when we're making these videos, yeah, and obviously, I don't know if you get the concept. I mean, I'm trying to explain something. So you can ask questions. I mean, and then I will explain. Yeah, because that's the whole point. You can ask the one they don't understand. Because remember, when you are watching the video, eventually, do you even watch the videos? No, Peter, you should, because if you, I mean, you understand, I might not have a separate time to sit you down and yes, we will have classes. We are going to resume our classes by Feb. But before the classes resume, at least you can learn from the actual repairs. Can I have that board? No. Let's no no. Let's yeah. So we want to grab one of the CD3215 here, and yeah, and then so we're taking the CD3215 from Odono board. Now I do have new sets of CD3215, but they never give me the result I want. So oftentimes you have to install. Uh, I don't know. I think it's just I just prefer to use something that is confirmed to be working, other than having to try my luck on new components or new chips. So I'm grabbing a CD3215 from a non-touch bar. These CDs are definitely working. Then we will install this and then try it again and see if we have any changes. Now, when it comes to in terms of, so the non-touch bar, and this is a non-touch bar board, and this is obviously a touch bar. Now, this board, they are not as strong in terms of taking heat. So when you are working on this board, and then you should be very careful the amount of heat that you apply to the board. Otherwise, you might just get your board popped off, and then it becomes a problem for you. So be very careful when you are working on this board. And then obviously now, when you are installing your components, it's usually what you have to be you have to be aware of the orientation of the components. Now, usually component manufacturers, they usually have a dot here. So you see this dot. Whenever you find a dot, that dot tells you that that is the pin 1 of that component. Whenever you have you, so usually when you look at the component, you will see that there's usually going to be a dot. Now, on the other side, the good thing with this one, on the other side, when you check, you see that there is also a cutout here that tells you that that is the pin 1. Now, on your logic board, you will say on the board view, for example, if I click on it, so this is going to be pin 1. So orientation wise, you have to make sure you orient it that your pin 1 will be on this side. So wherever you find the dot, that is going to be your pin 1. So just like this, yeah, that's pin 1. So here you then now you orient. So this is the logic board, the way it's faced. That is exactly the way it is. Okay, no, that's a different one. It's flip it on the other side. No, yeah. So this one, this. So our pin 1 is gonna be on this side here. I'm just gonna zoom in. So this is the board, yeah. So this is the CD that we're busy with. So we just zoom out. Pin 1 is going to be this. Now that dot, so you flip the dot to be that the dot has to be on this side to match your pin 1.
Okay, and just saying, if you put one pin on the other side,
Yeah,
is it going to affect anything?
it's not going to work to start with. Whether it affect nothing or not, to start with, it's not going to work. Now, on the board, I see that the sleep sensor has also been affected. It's actually broken off, but I'm not worried about that now. First and first, I want to get the machine to start before I worry about the sleep. But I mean, I can just address it while I'm at it. Yeah, let's just address it at the same time. By the way, this board has been to a previous repair shop. Um, yeah, before coming here. Okay, so what you want to do is you want to be sure that we don't have a short. Say for example, if you install the CD3215 incorrectly and then you have a ball bridging underneath, you might have a short. So what you want to do is before you connect the charger, you just want to just be sure that you don't have a short in the outputs. Okay, so we have a short. So we have a short here, and okay, we have a short. Mm, let's see. That doesn't seem like a short. Uh, okay, that's good. We should get OL any moment from now. Yeah, okay, that's not a short. Let's see on the other side. Okay, we don't have a short. Okay, okay, that's good. OL, we don't have a short. Open line. Now let's see if we have. Let's see if there's any changes. Okay, I want to see if I have my PP3V42 line present. Plugging into the same ports. I will just replace the CJ215 now. Okay, we have our PB3V42 line present, which means we have power going in from the port that we just replaced now. But now let's see if we have PP bus. The value we have on our PP bus is just going to be, it's just going to tell us if we have 12.66, then it tells us that yes, we have 20 volt on our PVDC8. But if we have 12.2, then it tells us that we have 5 volt on our PPDC8. So let's see what we have, 12.6 or 12.2. 0. That just tells us that we don't even like. I mean, we're not even going anywhere. So we have 5 volt on our port. Because if we had 20 volt, we should have our PPDCA. Okay, that is um okay. So it's not a blank rule that if you don't have PP bus, it means you don't have PPDCA. No, but just relative to what we're working on now. I'm just gonna just see what we have. So yes, we still have 5 volt, and okay. Now let's see if we're still in the same state we were before. Okay, it's good. We're still in the same state we are before. Let's just try to resolder the CD3215. Okay, now let's see if we have. Now let's just before we do that, let's see if we have at least. Let's see if we have uh, any of the LDO signal. Mm, that is fluctuating. Okay. Uh, okay. That's okay. That's let's see. Okay. And then the other side. Okay. And then what do we have here? 3 volt and stable. And then what do we have? Stable. It's again 5 volt to 19. Let's check again. 5 volt, 19, 5 volt. Okay, let's see. What do we have in the 342 present? Uh, Present. Okay. So let's see. Do we have 1.8 UPC? Let's see if we have 1.8. Do we have a 1.8 volt? Can measure that at this curve. Yes, we have a 1.8 volt. Let's see. Do we have PPDC in this 5 volts? Don't worry about that. This is present. Okay. Okay, let's see if we have this. I didn't expect us to really have that, but let's just check. And it's present. Okay. It's Okay. Mm, 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 PP3 is present. Mm, okay, 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 okay. So let's just check one more time, see what we get in. 5 volt stable. Let's check the other port. 5 volt. And okay, it's still fluctuating. Let's check the other ports just to be sure that we're still in the same state. Flip it so we can get the corresponding fuses to measure from. 5 volt fluctuating. Yes, okay, let's check the other port. Let's see if we have 5 volt and fluctuating. 5 volt and okay, that's good. Now let's go back to the CD that we had replaced. Let's just confirm one more time. Corresponding port to the CD. 5 volt and not fluctuating. Okay, so what we want to do is we want to, let's see, 30 volt. Okay, and then the other present, present, present. Present. Okay, just to confirm, to see if we don't have any short here. Okay, that's a good thing. Okay, we seem to have a short on that line. Let's see what is shorted. That's the USB line. We're not supposed to have that. Let's check in both diode mode, red probe to ground, and then black probe on our point 0.011. That's too low. This is what we should be getting. That's a donor board. Uh, Now on that line, we shouldn't get such low voltage, low reading. So we should get 0.37. However, on the board that is faulty, we're getting 0.01. So let's see why that is. Now that's the USB-C port. That's the USB line, which is so. So what we want to do is we want to remove this inductor and then find out which side of the board the short is. So let's remove this inductor. So let's try and address that first before we worry about the port not working, because that may impact the function of that port. So first and first, let's see why uh, which side of the board the short is by removing this inductor. And on your board view, the L alphabet is usually will be used to indicate an inductor on your board view. So what we want to do now is we want to remove the inductor and then check to see which side of the board has the short, and then we know how to tackle it. So now if we check on pin 2 of it, goes to this current sensing resistor, and then obviously it goes to our CD3215. So now let's see if our short is on this side. That explains why this is not working, because obviously because it detects a short, and as a result of that it's not boosting to 20 volt. Now if the short is on this side, uh, if the shot is on this side, if the shot is on this other side, then obviously we know that we have a problem here and not on this other side. So now let's see where we have a short. Same, we're still maintaining our diode mode. So in terms of accuracy, diode mode is very much accurate. Now, obviously, for diode mode, you have to make sure your red probe is on ground, and then your black probe is what you use as your guide. So let's see what we have. What side do we have it? So that's 0.188. Let's check the other side. Okay, that's not good. So our short is on the side of the CD3215. So what we want to do now is so let's remove this cap. So this is so basically in a situation like this, you wanna check you wanna find out where are the connecting points that you have your short. So when we click this, we can see that okay, our short. Let's just flip the board and then see, do we have nothing? No, nothing on that side. So which means this and this. Now for a resistor like this one, pin 1 and pin 2 is going to be exactly the same thing. So pin 1 and pin 2 is exactly the same thing. So whatever you measure here is exactly what you're going to measure here. And then so since we have nothing here connected to the line, then let's see what is connected to the line from here. So when we do that, we see we are connected. So the CD3215 is on the line. This cap is on the line, and then okay, we have this. So basically this is where the line goes through to the other side. Let's see what we have on the other side. Now on the other side, we have this being connected, this being connected, this being connected, and that being connected. We cannot blame this because this was doing its job. This was trying to boost. The only one that wasn't trying to boost was the other one. uh, so let's remove this cap. Okay, first thing first, let's see which when any of the see if any of the cap look funny. See if any of the cap look funny, and then we will take it from there. Okay, the cap doesn't really look funny, so I don't want to. It may also be that our CD3215 is what is not properly installed. But before we take it out again, let's just remove the caps. Let's just remove the caps that's on the line and see if we have any changes. Peter, what time is it? It's fine. I'm just gonna check it. 23. Okay, I need to leave for Salah in few minutes. So we remove that cap. Let's quickly measure again, see if we have any changes. Red probe to ground, and then our black probe. No changes. Okay, now let's try to remove the two on the other side. See if we have. So let's flip it. We're talking about this two here. Let's see if we have. And then we see, remove and see if I have any changes. It may well just be that our CD3215 is not properly installed. That may just be the case. It may be that there's a solar ball that is bridging underneath our CD3215. So yeah, let's just quickly check if there's any changes. If not, we just have to remove our CD to check. No changes. So let's just remove our CD and check to see if most likely there was a ball that's uh, misbehaving underneath the CD. Okay, so our CD is out. Now let's see. Installation was good on the CD. Yeah, let's just see what we have now. And the problem was our CD. Okay. We have to get another CD3215. So that obviously was not. So see, now the short is gone. So what we want to do is we want to put back the components that we had removed, and then get another CD3215. No, those are new. I don't trust the new ones. I prefer to use from donor boards. I thought that CD was working, the one I took, but apparently. And for your inductor, you don't have to worry about the orientation. There is no pin 1 or pin 2 type of orientation on your inductor. However you place it, you're good. You don't have to worry about if you place it right. The like you don't have to worry about the polarity basically. Yeah, however you place it, you're good. Hello?
Hello, Lucky.
Yeah,
Yeah, I'm fine.
I did.
See, I tell you guys, see, now you be only person wey fit buy that amount. And if you go to meet all those Pakistan and all those things that anyhow, it him fit sell. And 90K, me come tell 90K. Me now I tell you 9500, but me I no fit come sell something, I no go get something for inside. So if you transfer am 90K, give me 500. If you think interested, they can bring am come for you.
I'll call you back.
You understand?
I'll call you back.
Because normally, check am, you go feel okay, no wahala.
And by the way, I didn't have to re-ball the CD3215 because my balls are perfectly in place. So there's no need for me to re-ball it again. Which is why I'm very careful while I'm removing it so as to make sure my balls are safe. Okay, I'm gonna leave it to cool down. I'm just gonna quickly measure to be sure that we don't have a short no more on our USB line. 0. What's happening? Okay, yeah. Okay, it's gonna increase because the body is super hot now. That's why, yeah, it's gonna increase. It's just that doesn't seem like a short. So what I'm gonna do is I'm just gonna go for my prayers this time for Salah, and then when I come back, and then I can continue. Okay.